Hello students, I hope you are all good. In the today's lecture, we will discuss about differentiate between displacement and distance, types of quantities, speed and types of speed. So let's start with third point of differentiate between distance and displacement. Third point is that the magnitude of displacement can be positive, negative and zero, but distance is always positive. It never decreases with time. Let's take an example for positive and negative displacement. We assume that the direction of motion towards x-axis is positive, so the direction of motion opposite to x-axis is negative. A boy starts riding a bicycle from origin in the direction of x-axis 5 km, that is displacement is equals to 5 km, and returns opposite to the direction of x-axis 10 km, that is displacement is equals to minus 10 plus 5 is equals to minus 5 km. Negative sign only represents direction, and total path length or distance is equals to 5 km plus 10 km is equals to 15 km. For zero displacement, a boy is riding a bicycle on a circular path, starts from point A and end on point A. That is, initial and final position are same. Displacement is equals to initial position minus initial position is equals to 0. And distance is equals to circumference of circle is equals to 2 pi r, where r is the radius of circle. Fourth point is that distance is always greater than equal to displacement. This above equality holds when particles move in a straight line with changing its direction. In the above example, a boy starts riding his bicycle towards the diameter of circle from point A to B, then distance is equals to displacement is equals to diameter. And if he rides his bicycle on the boundary of a circle from point A to B, then distance is equals to circumference upon 2 is equals to pi r, and displacement is equals to diameter is equals to 2r. In this case, distance, that is 3.14 r, is greater than displacement, that is 2r. After that, let's discuss types of quantities. There are mainly two types of quantities in physics. First is that scalar quantity. A scalar quantity is a quantity which has only magnitude. Example: speed, distance, time, etc. Second type is that vector quantity. A vector quantity has both magnitude and a particular direction. Example: velocity, displacement, force, etc. After that, let's discuss speed. The time rate of change of position of the object in any direction is called the speed of the object, or the ratio of distance traveled by an object to the time taken is called as speed. It is represented by small v, and formula of the speed is equals to distance traveled small d upon time taken small t. SI unit of speed is meter per second. It is a scalar quantity. Its dimensional formula is LT minus 1. After that, let's discuss types of speed. There are 5 types of speed, and they are uniform speed, variable speed, average speed and instantaneous speed. Let's discuss them one by one. Uniform speed. An object is said to be in uniform speed when the object covers equal distance in equal intervals of time. Example: motion of heavy vehicle like trucks on the highway. Non-uniform or variable speed. An object is said to be in variable speed when the object covers a different or unequal distance in equal intervals of time. Example: motion of a bike in city or on busy roads. Average speed. Average speed is defined as the uniform speed which is given by the ratio of total distance traveled by an object to the total time taken by the object. It is represented by v suffix average. Formula of average speed is equals to total distance traveled upon total time taken. If a particle travels distances s1, s2, s3 and ordered so on with speeds v1, v2, v3 and ordered so on, then average speed is equals to s1 plus s2 plus s3 plus dot dot so on upon t1 plus t2 plus t3 plus dot dot so on. We know that the speed is equals to distance upon time and time is equals to distance upon speed. Then t1 is equals to s1 upon v1, t2 is equals to s2 upon v2 and dot dot so on. Put in average speed. So average speed is equals to s1 plus s2 plus s3 plus dot dot so on upon in bracket s1 upon v1 plus s2 upon v2 plus s3 upon v3 plus dot dot so on. After that, let's discuss some cases of average speed. Case number first, if a particle travels equal distances, that is s1 is equals to s2 is equals to s with velocities v1 and v2, then average speed is equals to s1 plus s2 upon s1 upon v1 plus s2 upon v2 is equals to 2s upon s upon v1 plus s upon v2 is equals to 2v1 v2 upon v1 plus v2. Case number second, if a particle travels with speeds v1, v2, v3 and dot so on during time intervals t1, t2, t3 and dot so on, then average speed is equals to v1 t1 plus v2 t2 plus v3 t3 plus dot so on upon t1 plus t2 plus t3 plus dot so on. Case number third, if the particle travels with speed v1 and v2 for equal time intervals, that is t1 is equals to t2 is equals to t, then average speed is equals to v1 t1 plus v2 t2 upon t1 plus t2 is equals to v1 t plus v2 t upon t1 plus t2 is equals to t in bracket v1 plus v2 upon 2t. Average speed is equals to v1 plus v2 upon 2. Case number fourth, when a body travels equal distance with speeds v1 and v2, the average speed v average is the harmonic mean of two speeds, that is 2 upon v is equals to 1 upon v1 plus 1 upon v2.